Hi guys, welcome back to another video tutorial about network troubleshooting. In this tutorial I'll introduce ping and I will explain the mechanism and show you practically how to use this command. So in case you haven't used it, stay tuned as I'll show you how to use it, and hopefully by the end of this video you'll have an excellent worldview of how to go about pinging. But first let me start with a bit of history. Ping stands for Packet Internet Groper and was first developed by DARPA to test the performance of the ARPANET. In case you don't know, the ARPANET was the precursor of the internet. And the acronym ping was given to match the term ping used by submarines for the sound of a returned sonar pulse. Right, so the ping command is just a network application that tests the connectivity between your computer and another node or host in your network. Right, so it works by sending an ICMP echo request to a specified interface in the network, and it will wait up for a reply. So virtually the ping command works exactly like as a sonar echolocation. You have host A that sends an echo request to a host B in your network, let's say, and if host B is active, it will send an echo reply packet in return. So echo, this becomes an echo reply, sorry, and it will go to host A, right? So virtually host A asks host B, hey, are you there? And if host B sends this echo reply, it's virtually saying, hey, yes I am. Right, so let's get down to business and test ping. Right, but first let me just mention that if you're on Windows, you should open command prompt for this demo. And if you're on Mac or any Linux machine, just open a terminal for the next commands and follow suit. Right, so the command is ping, and it can be used in conjunction with a number of options, but its simplest form should suffice, and that is when you give either a domain name or an IP address as a parameter. So you could use it like this, so ping hostname, where hostname is typically the address or a site or a server you'd like to ping, or you could use it with an IP address, right, like this. And needless to say, the IP address is the address of that device in the network. For example, if I want to ping my router to check my internet connectivity, I could simply type ping 192.168.0.1. This is my router's IP address. Of course, you need to insert your own router's IP address, and I have shown you in the previous tutorial how to do that. If you haven't seen that video, please go back and see it and return here. Right, so after running this command, if after running it you get no response, you know that the router is causing the issue. So as you can see here, after run the command, ping has continuously sent echo request via very small packets to our router, and our router has sent replies, as you can see here, for each packet it has received. In Unix, unless we stop the ping, it will be continuous. We can stop it by pressing Ctrl+C, and like I have here at the bottom, this is a Ctrl+C, or a SIGINT, signal interrupt. So this Ctrl+C basically sends a SIGINT or signal interrupt to our router to terminate the ping, and the SIGINT signal is sent to a process by a terminal when the user wants to interrupt the process. You only need to do that on Windows because in the command prompt, the ping will automatically stop after it tries to send 4 packets. Right, so let's go up here, and let's say we want to read the standard output. So basically we have sent 56 bytes of data, and we got a reply from my router with this IP address. worth of 64 bytes of data. The next column is the ICMP sequence number. Then you have the TTL equals 64, and then you have the time, or this is the round trip time. Let me talk about the last two bits. So TTL is time to leave, and it represents the number of hops that occur during the packet transfer process. And the lower the number, the more routers the packet has passed through. And the last column is time, and this is how long in milliseconds the connection took. Right, so that's fairly easy to grasp. Then at the bottom, you have the statistics for this IP address. As you can see, we have sent 19 packets, we have received 19 packets, and no packet was lost, 0.0% packet loss, which means our connection is quite reliable. Then the last line shows the round trip time, and the shortest round trip time was 2.61 milliseconds. The average was 13.18 milliseconds, and the maximum was 80.56. The last measurement here is the standard deviation of 17.31 milliseconds. Right, so this is how ping works. Please remember, it sends very small data packets, and after you get the response, you know that the device on the other end is active. Right, so let's try and ping google.com and see what happens. Let me clear the screen first. Ping google.com. Right, and now let me just stop the command, and as you can see, this is our standard output. Right, so we have a similar printout, but as you can see here in the right, the round trip time is higher because google.com is located further away from my computer than my router is. Right, so we could try to use an option, and one that comes into my mind is -c, ping-c, let's say for google.com. And what this option will do is it will virtually tell ping to send 4 echo requests to google.com and then stop sending. Let's try it and see if it works. And as you can see, it receives, so it basically sent 4 echo requests. So it sent 4 ICMP echo requests to google.com, and then it stopped after these 4 packets, and now we have a similar output as before. Right, so there's such thing as an audible ping, but you won't be able to hear it because I have my microphone on, and you can test that with the -a command, so -a google.com, and this basically should make a sound after each successful reply from the destination. Right, so now let's try to ping a device that doesn't exist. So let's say we want to ping 192.200.200.200, and let's press enter, and let's Control-C and stop the process. Well, as you can see here in the standard output, we received a timeout message, which is in our case request timeout for each sequence number that we send, and this basically means that this device doesn't exist. If we stop the ping, in the summary we see that we have tried to send 7 packets, we received no reply in return, and we have 100% packet loss. And this means that either the destination doesn't exist or the destination has connectivity issues. Right, so that's all for today. As you can see, ping is quite simple, but very valuable to use for network troubleshooting. In the next video, I'll expand your knowledge and introduce you more to the world of complex world, I should say, of network troubleshooting. I hope you have enjoyed this video. Don't forget to subscribe, and I'll see you in the next video.